1,600 meters under a protected national park, a £9 billion monster is tearing through the earth. This is the Woodsmith mine, where machines 60 meters tall and weighing 350 tons battle crushing pressure in total darkness. It is the deepest hole ever dug in Britain, but it might also be the world's most expensive mistake. We are talking about a massive engineering gamble designed to solve a global crisis: how to feed a planet running out of farmland. With a 37-kilometer tunnel that broke world records, the stakes could not be higher. Will this giant gamble pay off, or will the North Yorkshire moors swallow up one of the most ambitious projects in history? The story of this massive hole in the ground began over 10 years ago with a big dream from a small company called Sirius Minerals. They found a treasure hidden beneath the beautiful rolling hills of the North York Moors National Park. This treasure was a massive deposit of polyhalite. Polyhalite is a very special kind of natural fertilizer that formed millions of years ago when ancient seas dried up. The deposit under North Yorkshire is the largest and highest grade of its kind in the entire world. The company leader, Chris Fraser, promised this discovery would change the future of farming and feed the world for over 50 years. To pay for the digging, he convinced 85,000 small investors to put their money into the company. Many of these people lived right in the local area. They believed in the project so much that they put their pensions and life savings into it. The goal was to reach a mineral seam that is 70 meters thick and covers over 25,000 hectares. But digging to such extreme depths turned out to be much harder and more expensive than anyone ever imagined. By 2019, the company was in a desperate situation and completely ran out of money. Just before the company went bankrupt, a giant mining company called Anglo-American bought the project for £405 million in 2020. This takeover saved the jobs and the project, but the engineering team still faced a massive mountain of work. They had to figure out how to build Europe's deepest mine inside a protected park where strict rules protect the environment. How exactly do you build a massive industrial site while hiding it from everyone on the surface? The answer is a design called invisible mining. The engineers decided to hide the mine heads underground in deep pits instead of building tall towers. They also chose to use dark materials for any small buildings above ground to make them look like simple farm barns. To reach the polyhalite, they are sinking two main shafts at the same time. The production shaft is designed to reach 1,594 meters, and the service shaft will go down to 1,565 meters. Both of these shafts have a diameter of 6.75 meters. Instead of using loud explosives that would shake the ground and disturb the park, they are using a giant robot called a shaft boring roadheader. This machine is a 60-meter tall tower of steel that weighs 350 tons. It hangs from massive steel ropes and slowly eats its way down through the rock. At the bottom of this robot is a long arm with a spinning drum covered in very hard teeth. This drum spins with a power of 600 kilowatts and a force of 100 kilonewton meters. It grinds the hard rock into tiny pieces with incredible precision. No workers have to stand at the bottom of the shaft, where it is dangerous and hot. An operator sits in a safe control cabin on a high platform and uses cameras to guide the machine. This makes the work much safer than traditional mining methods. As the machine digs, it uses a huge vacuum system to suck up all the broken rock. This pneumatic system moves 35,000 cubic meters of air every hour to keep the bottom of the hole clean. The waste rock is pulled into a suction tank and then sent to the surface in large buckets called kibbles. Every time the robot digs down about 1.2 meters, it has to stop. The crew then attaches the machine to the shaft walls and lowers it further to start the next cycle. This repetitive process is highly automated to make sure every meter is dug perfectly. But how do they stop the walls of this massive hole from collapsing under the weight of the mountain. The engineers use thick concrete rings and heavy steel segments called tubbings. Each of these tubbing segments weighs 2.9 tons and is about 1.2 meters high. 15 of these segments are bolted together to make one complete ring that lines the shaft. These rings are built from the top down as the machine descends. This allows the team to seal off the shaft walls immediately and keep the workers safe. One of the biggest enemies in this project is water. The ground in this area contains the Sherwood sandstone, which is a giant layer of rock filled with water. If this water gets into the mine, it could flood the entire operation in minutes. To prevent this, the team uses retractable robotic probes that drill holes ahead of the main machine. They pump a special liquid called grout into these holes at high pressure. This grout fills every tiny crack and hole in the rock, creating a waterproof seal before the digging starts. They even use a special grout pattern that looks like a spiral to make sure they catch every possible fracture. This part of the engineering is a world first and is essential for digging the deepest commercial shafts in Europe. But once the mineral is out of the ground, how do they get it to the coast without using thousands of noisy trucks? The solution is an underground highway called the Mineral Transport System. This is a single tunnel that is 37 kilometers long. It is being built at an average depth of 250 meters below the surface. To create this record-breaking tunnel, the engineers are using a massive machine named Stella Rose. She is a tunnel boring machine that is 6 meters wide and 225 meters long. She weighs a staggering 1,775 tons. At the front of Stella Rose is a giant cutting head with 34 hard rock discs. These discs spin around and crush the rock as the machine moves forward. She has been working underground for over 5 years and is still going today. In December 2023, Stella Rose broke a world record for the longest single drive by a tunnel boring machine when she passed 25.8 kilometers. By December 2025, she had reached the 30-kilometer mark. As Stella Rose moves forward, she leaves behind a perfect tunnel lined with concrete. This lining is made of over 150,000 segments that were built in a high-tech factory. Each ring in the tunnel is made of 6 segments that are 35 centimeters thick. These segments have to be incredibly strong because they face water pressure that is 29 times higher than the air we breathe. To make them, the project built a robotic factory that uses automated welding to create steel cages in less than 10 minutes. The segments are reinforced with steel to handle the massive weight of the earth above them. Inside the completed tunnel, a giant conveyor belt will carry the polyhalite at a speed of 21 kilometers per hour. This belt will stretch the entire length of the 37-kilometer tunnel. There is also a small maintenance railway that uses very clever hybrid locomotives. These trains use a system called kinetic energy recovery. This means they save energy when they go down steep parts of the tunnel and use that power later to go back up. Building a tunnel this long creates unique challenges for the team. For example, they have to pump concrete grout for 15 kilometers through the tunnel just to reach the machine. This is a distance that has never been tried before in the history of tunneling. The power to keep all these machines running comes from a huge 66 kilovolt cable. This cable is made of copper and is protected by layers of lead and special plastic insulation. It runs through the entire tunnel to supply electricity from the coast to the mine site. Everything in this project is designed to protect the local environment. Even the waste rock from the tunnel is being used to cover up old contaminated land near the coast to create new industrial sites. But what exactly is the purpose of all this effort and expensive engineering? The goal is to extract the world's most sustainable fertilizer. Polyhalite contains 4 of the 6 most important things that plants need to grow. These are 48% sulfur, 14% potassium, 6% magnesium, and 17% calcium. Most chemical fertilizers are made using lots of energy and high heat, which releases many greenhouse gases. But polyhalite is a natural mineral that is just crushed and turned into small pellets. This process produces 85% less carbon than other common fertilizers. It is even certified for organic farming, which is why countries like China, Brazil, and Japan are very interested in it. Once the mine is fully working, it will produce 13 million tons of this fertilizer every year for more than 60 years. This could help farmers grow 56% more food to feed the billions of people on our planet. It also helps the soil stay healthy instead of making it acidic like some other chemical products do. But even with all these benefits, the project has hit some very difficult times recently. The total cost of this massive gamble has now reached about £9 billion. Because the cost is so high, Anglo American had to make some tough choices to save money. In May 2024, they decided to slow down the work and put parts of the project on life support. However, things started to look better in early 2026. A Japanese company called Mitsubishi Corporation decided to invest in the project. They are now working with Anglo American to finish the studies and find the best way to move forward. If you want to see more incredible builds, subscribe to the Building Impossible channel, leave a comment below, and turn on notifications.